Imagine this. You try to push your hand through air. Easy. Try the same thing underwater. Suddenly it feels heavy and slow. Why does water fight back while air barely notices you? And how does a giant metal ship float while a tiny stone sinks instantly? Welcome to Fluid Mechanics, the physics of anything that flows. This is the learning studio, where every complex topic becomes crystal clear. Let's break fluids like you're 5. A fluid is anything that can flow. Liquids and gases, water, oil, air, steam, all are fluids, and 4 simple ideas explain their behavior. 1. Density. Density tells you how packed a substance is. Think of density like crowding. A crowded bus, high density. An empty bus, low density. Water is crowded, air is not. That's why you feel heavier resistance in water. Heavy fluids, more pushing power. Light fluids, less pushing power. 2. Pressure. Pressure is how much force a fluid puts on every bit of your body. Deep underwater, the pressure increases because the weight of water above you increases. More fluid above, more pressure. This explains why your ears hurt underwater, why dams are thicker at the bottom, why air pressure drops on mountains. Pressure is simply the push from fluid around you. 3. Archimedes' principle, why things float. This one is beautifully simple. A fluid pushes upward on anything inside it. That upward push is called buoyant force. If upward push, weight, object floats. If upward push weight, object sinks. Stone sinks because it's dense. Ship floats because it's mostly hollow inside, low average density. It's not about size. It's about density and upward force. That's why boats float, helium balloons rise, hot air balloons lift, submarines dive or rise by changing density inside their tanks. All Archimedes. 4. Viscosity, fluid thickness. Why does honey pour slowly? Why does water splash fast? Why does oil feel smooth? Viscosity equals how sticky or thick a fluid is. Honey, high viscosity. Water, low viscosity. Air, very low viscosity. Engineering uses viscosity everywhere. Car engines, lubricants, pipes, blood flow in arteries, jet turbines, airflow over wings. Viscosity decides how fluids resist motion. Fluid mechanics in real life. This is not textbook stuff, it's everywhere. Airplanes fly because air behaves like a fluid. Rockets push gas, a fluid. Backward hydraulics lift cars using fluid pressure. Doctors measure blood pressure using fluid principles. Weather forecasts depend on airflow and pressure. Ships float using Archimedes' principle. Even perfume sprays work due to pressure differences. Fluids control our world. Now here's your curiosity hook. If pressure increases the deeper you go, what happens at the bottom of the ocean? How do submarines survive crushing forces? And why can't humans dive very deep? We'll open that mystery next. This is the Learning Studio. Subscribe and continue the physics series. Simple, sharp, and worth every minute.